Okay, in this lesson, let's talk about linear speed. So here's what we're going to do. We're going to imagine that we have a tire with a radius of 9.4 inches. Then, what we're going to do is we're going to take the truck to which the tire belongs, and it's lifted up from the ground. The engine's turned on and the pedals pressed down so that the tire begins to spin. Now, the speed at which a point on the rim of the tire travels every second as the tire rotates, that's called the linear speed. So imagine a point here on this tire that has 10 revolutions per second. So it goes around full circle 10 times for every second. The question is, how fast is the tire rotating in miles per hour? We're going to use this concept. One full revolution is equivalent to 2 pi radians in angle measure. Okay, that's a key concept here. Now, if we took this tire and we laid out the circumference of the tire in a line, then the number of revolutions would be 10 times the circumference in length. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the circumference of one tire here, represented 10 times. That's 10 revolutions. So, arc length S divided by T, from the previous lesson, we know that arc length is radius times central angle theta over time. And so we plug in what we know. 9.4 inches times 10 revolutions times 2 pi is the full radian measure, divided by 1 second. We're going to get about 1,218.94 inches per second. But we want miles per hour. And so we're going to do a conversion. We're going to use these standard conversion units right here. And so the first thing we do is we write up a table. And so 1,218.94 inches over 1 second. To get rid of the seconds, we multiply the top by 60 seconds and divide by 1 minute. That'll divide out the second unit. And then to get rid of the minute unit, we multiply the top by 60 minutes and divide by 1 hour. To get rid of the inches units, we multiply the top by 1 foot and divide by 12 inches. And then to get rid of the foot units, we multiply by 1 mile and divide by 5,280 feet. So we take this table and we write the following calculation. 1,218.94 over 1 times 60 over 1 times 60 over 1 times 1 over 12 times 1 over 5,280. That's going to turn out to be 69.3. And so the linear speed of this tire is 69.3 miles per hour. So, okay, we're going to use the Greek letter nu. It's pronounced nu. It looks like a V to represent the linear speed. And so this is one of the key formulas you need to use for linear speed. Nu, linear speed, is arc length over time, S over T, or change in arc length over change in time. So, okay, let's look at another example. And in this example, we want to be able to find the needed number of revolutions to make the problem work. A factory is producing a new 12-inch radius tire that will reach up to 15 miles per hour. How many revolutions per second are needed to reach this speed? So let's break the problem up into steps. First, 15 miles per hour can be written as a ratio of 15 miles over 1 hour. And that right there is arc length over time, S over T. Now we're going to do a conversion. We're going to go from miles per hour back into inches per second. So, S over T is 15 miles per 1 hour times 1 hour for 60 minutes times 1 minute for 60 seconds times 5,280 feet per 1 mile times 12 inches per foot. And this gives us a nice value of 264 inches per second. Now, using the formula arc length is radius times central angle, we just substitute in what we know. We know that the arc length is 264 inches, and we know the radius is 12 inches, so we divide, and we get the central angle of 22 radians. To figure out how many revolutions that is, once you have the central angle, you divide by 2 pi, right? Because the conversion formula here says 1 revolution is 2 pi radians. So if I have the arc length, I divide by 2 pi, and that gives me 3.5 revolutions per second.